Good morning, class 9 students. In today's chemistry lecture, we would be moving on to a new chapter because we concluded in the last part or the sixth part of the fifth chapter of periodic table, wherein we learnt about the various uses and importance of periodic table. Now today, this new chapter is known as study of first element hydrogen. Today we will mainly concentrate on the element hydrogen in the periodic table. So we see, children, that the position of the non-metal hydrogen we all know is a gas, so it's a non-metal in the periodic table. And we see that some of the characteristics of hydrogen are very unique. It has got atomic number 1. As we see here, it has got atomic number 1 and number of valence electrons is 1. We see that in hydrogen, its valence electron, or it has got only 1 electron in the only shell which hydrogen has. It is the first element of the periodic table. We see that here it is the first element. If you have a look at this periodic table, children, then it will be made more clear to you. Do you see here, children, that here we see that hydrogen is coming on top of group 1. So here we see that hydrogen has got 1 number of valence electron here, and it is the first element of the periodic table which is placed in group 1 of the periodic table. Then we also see that hydrogen has got dual nature. What is dual nature, children? It exhibits nature of 2 different sets of elements. Hydrogen, it has the electronic configuration 1. So either it loses its 1 electron or it gains 1 electron. When it loses its 1 electron, then it acts like the alkali metals in group 1, which also have got 1 electron each, 1 in the outermost shell of lithium, 1 in sodium, 1 in potassium, like that. They also lose 1 electron and they become electropositive by losing 1 electron. So we see hydrogen, it acts like one of these, and it also acts like the electropositive element hydrogen. It is put in 1A group. Then we see that also there is an example of hydrogen wherein it gains electrons. It becomes this side of the periodic table that we see the hydrogen has also been put on top of the halogens or the 17 group of elements. So here each element, fluorine, chlorine, bromine, iodine, they take 1 electron because they have got 7 electrons in their outermost shell. So each one is ready to accept 1 electron so that they complete their outermost shell. Their octet becomes exactly like their corresponding inert gas. Fluorine wants to become like neon, chlorine like argon, bromine like krypton, and iodine like xenon. So we see here that hydrogen also gains, it can gain 1 electron, and hydrogen becomes like helium. So children, let us quickly look at this dual nature once again. Example, hydrogen, when it loses 1 electron, here in this equation we are showing that hydrogen is losing 1 electron. Can we have a closer look? You see here, it is now positively charged by losing 1 electron. Now, children, here we see in lithium the electronic configuration is 2-1. That means alkali metal lithium, it also loses 1 electron from its outermost shell to become an electropositive uh, ion. Then we see sodium also 281 is its electronic configuration. That also loses one electron to become sodium ion, electropositive ion. Likewise, we saw the other nature of hydrogen. It gains one electron, behaving like electronegative halogens that I had shown you in the periodic table. Here, this is in group 17 or 7a elements. We see hydrogen, when one more electron is added to it, it becomes H1 negative. You see that after addition of one more, it becomes H1 negative. Likewise, in halogens and fluorine, we see we have 2, 7. So fluorine needs one more to complete its outermost shell. So fluorine atom plus one electron added to it, it becomes a electronegative fluorine ion or an electronegative ion. Then we see in chlorine 287, this also requires one. So when one electron is added, chlorine becomes an electronegative ion. So this property is also shown by hydrogen. It becomes like its nearest gas, helium. Now helium in its outermost shell has got 2 electrons. So when hydrogen gains one more electron, it becomes like helium. What is the resultant position of hydrogen? Hydrogen shows similarities with both alkali metals of group 1 as we saw and the halogens of group 17 as we saw. We see that alkali metals of group 1, above these hydrogen is placed just over lithium in group 1. And also we see that the halogens of group 17, hydrogen is placed above fluorine in group 17 because it resembles the property of the halogens also. Now we see the characteristics showing similarities of hydrogen with alkali metals. What are the similarities? The electronic configuration. Valency electrons, one valence electron is present in hydrogen. Likewise in lithium there is one valence electron in the outermost shell. Sodium also one valence electron in the outermost shell, and potassium also one electron in the outermost shell. Then we see the ion formation character that also hydrogen resembles. Let us check out here the electropositive character exhibited here. Hydrogen, by losing one electron, it becomes a proton because hydrogen is only left with one proton in the nucleus. Likewise, we see lithium is also becomes electropositive. Likewise, sodium becomes electropositive. So this is a similarity that we see of hydrogen with the alkali metals. Then we see valency. Electrovalency of one is exhibited. Like in hydrogen, it becomes an electrovalent carrying one valency. And what is this valency? A positive valency. Likewise, lithium also after losing one electron shows a positive valency or electrovalency. Likewise, sodium also shows a positive ion, and potassium also. Then we see the reactions also are similar, like strong affinity of the non-metals. Example, oxygen, sulfur, chlorine. These three non-metals, they have got a close affinity or a close bond when they make compounds with hydrogen. Or oxygen, sulfur, chlorine also make compounds with sodium. For example, hydrogen forms a compound with oxygen named water, and with sulfur, hydrogen forms a compound H2S, and with chlorine it forms a compound hydrochloric acid. Likewise, we see sodium also behaves in similar fashion. Sodium forms sodium oxide with oxygen, sodium sulfide with sulfur, and sodium chloride or NaCl or salt with chlorine. Likewise, we see that the reducing agent, it also acts like a reducing agent. Acts like reducing agent, for example, hydrogen in copper oxide. When hydrogen gas is passed, we see that hydrogen gets oxygenated to form water and copper is reduced. Likewise, sodium also does the same thing, alkali metal. So this is a similarity with alkali metal of hydrogen, that copper oxide, when sodium is reacted with copper oxide, then copper is reduced and sodium gets oxidized, making sodium oxide. Now, children, there is a similarity of hydrogen with halogens, group 17 elements. Now, what is this similarity? We see the electronic configuration. Hydrogen has got an electronic configuration of 1, just like helium. And hydrogen, it needs 1 electron to become like helium. Likewise, fluorine, it has got the electronic configuration 2, 7. It also requires 1 electron to become like neon 2, 8 to complete its outermost shell. Likewise, chlorine, it has got electronic configuration 2, 8, 7. And when it gains 1 electron more by allowing 1 electron to enter in the outermost shell, then it becomes like the nearest noble gas, argon, with electronic configuration 2, 8, 8. Then we see that the ion formation character is also similar between halogens and hydrogen. For example, hydrogen, when it gains 1 electron, it has got 1 negative charge. So it shows electronegative character of hydrogen. Same character is shown by fluorine. Fluorine, when 1 electron is added to it, fluorine becomes electronegative with a negative valency of 1. Likewise, chlorine, when 1 electron is added to the outermost shell, it also shows 1 electronegative ion by gaining 1 electron. Then we see similarity of valency between hydrogen and the halogens. The electrovalency and covalency is seen here. What is electrovalency, children? Electrovalency is when any element, it breaks into ions, and these ions, they make compound with other atom of the element. This is electrovalency, and electrovalency happens by transfer of electrons from one atom to another, whereas covalency, if you remember, children, happens by sharing of electrons between atoms. Now, electrovalency, covalency is shown by hydrogen. Let us look here. Hydrogen forms sodium hydride, which is an electrovalent compound. Sodium, it transfers 1 electron to the outermost shell of hydrogen. Likewise, we see that here hydrogen is showing covalency. It combines 4 hydrogens combines with carbon by sharing of electrons. So 4 single covalent bonds are formed. If you remember, we formed them like this when we had studied about the bonding chapter. So this was covalency. 1, 2, 3, 4. 4 single covalent bonds by sharing 1 pair of electrons between carbon and each hydrogen. Then we see chlorine. It forms sodium chloride, which is also an electrovalent compound, salt or sodium chloride. Then we see chlorine also forms a covalent compound with carbon, like we see here carbon combines with 1, 2, 3 and 4 chlorines. So 4 single covalent bonds are formed between chlorine and 4 carbon and 4 chlorine atoms. Then we see atomicity is another characteristic that is common between halogens and hydrogen. Hydrogen also forms diatomic. What is atomicity? Making molecules like we see diatomic molecule is made by hydrogen. Two hydrogen atoms, they combine through covalency by sharing of electrons, and they form a single covalent bond among them. Thus hydrogen gas is produced. Likewise chlorine, we see two chlorine atoms, they combine together sharing one pair of electrons to form chlorine-chlorine bond or chlorine molecule. Some more important things about hydrogen is its discovery. Hydrogen was initially called inflammable gas. Now there was a scientist by the name of Robert Boyle who in 1672 he established the elementary character of hydrogen, that hydrogen is inflammable in nature. Another scientist, Henry Cavendish, in 1776, he first prepared hydrogen in the pure form or the pure state. He formed hydrogen and also described its properties and recognized it as an element. This was Henry Cavendish children. Then he found that the gas was inflammable and burnt in air to produce water. Leviezer was another scientist. In 1783 established the name hydrogen, which means hydro meaning water and gen means water producing. So hydrogen, we very well know, it combines with oxygen to produce water. Then we also see free occurrence. Either it is in combined state, hydrogen is found, or in free state. So here quickly today we will see how hydrogen is found in free state. Hydrogen stands ninth in abundance by mass among the elements that are present in the Earth's crust. We see it makes up approximately 1% of our Earth's crust. Which element? Hydrogen. We also see that hydrogen is seldom or very few times it is found in free state on the Earth. It is usually found, because it's so reactive, it's found in combined state most of the time. It exists up to 0.01% in the Earth's atmosphere. Then we also see that hydrogen is found in minute traces in volcanic gases also. So we see that hydrogen is present in free state in all these areas of our Earth's atmosphere and the Earth's crust. So children, today we will finish this video till here only, and then we will continue with the occurrence of hydrogen with combined state in the next video. So wish you all the best for understanding this video. Have a good day. Thank you.